Hello, boys and girls. Chapter 7, Lesson 10, Problem Solving, Fractions. You know, I love the problem solving pages because they take everything you learned and they put them into real life problems. So they are awesome. You guys are going to do great on this. Here we go. Let's start reading this. Chad buys peanuts in 2-pound bags. He repackages them into bags that hold 5/6 pound of peanuts. Let's look at that. He repackages. Remember that prefix re? It means again. So he packages them again. So he has a big bag of 2 pounds. And he opens up that bag and he makes smaller bags that hold only 5/6 pounds. 5/6 pounds. So he takes that bag of 2 pounds and he breaks it apart into smaller bags. That's what repackaging means. How many 2-pound bags of peanuts should Chad buy so that he can fill the 5/6 pound bags without having any peanuts left over? So he doesn't want any peanuts left over. He can buy, as many 2-pound bags as he wants with no extra sixths, no extra sections of peanuts left over. All right, let's see here. So I'm going to draw a bar instead of a bag. I think it's just going to be easier to visualize, okay? So that's one of Chad's bags. And remember, guys, it's 2 pounds. So that line there is separating the 2 pounds. Okay, so what did Mrs. Olvey just do? This 1 pound, I separated into 1, 2, 3, 4, 5, 6 equal parts. Why did I choose that? I'm looking in the problem. Chad's dealing with 6 equal parts, isn't he? He is making sure each bag is separated into 6 equal parts for when he repackages them. So each of these pounds is going to be separated into 6 equal parts. And let me check this pound. 1, 2, 3, 4, 4, 5, 6. Okay. Now we're going to go 1, 2, 3, 4, 5. That is one of these bags. Okay? And now I'm going to change colors and count 1, 2, 3, 4, 5. So I used 1/6 from over here, counting to 5/6. So that's one little bag he made, one of these. There's a second little bag he made. So if Chad only buys 2 pounds, right, in the one bag, he's going to have pieces left over, isn't he? Right? So he's got to buy another 2-pound bag. I know these are rectangles and not bags. Okay, what's that line for? It's separating the 2 pounds, right? So 1. Remember why that I did that? That's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Those are separated into sixths, just like Chad separates the peanuts. All right, so I'm going to try to make more bags with 5/6, but I'm going to start right here because remember I had these 2/6 left over. So let's count 5/6 for another repackaged bag. 1, 2, 3, 4, 5. So he made a third little repackaged bag, right? And let's change colors. 1, 2, 3, 4, 5. Right there. Now, how many do I have left? 1, 2, 3, 4. He is still going to have some left over even after he buys 2 bags of peanuts. So he has repackaged 4. All right, let's make another bag. So Chad is going to buy at least 3 2-pound bags. Okay, pound 1, pound 2, and we're separating into 6 equal parts. So I can draw 5 lines. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. 6 equal parts, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okie dokie. More repackaging. So I'm going to start here, and I'm counting 5 equal parts, right? Because I'm repackaging into 5 6-size bags. 1, 2, 3, 4, 5. Okay, that's the 5th bag. A new bag now. 1, 2, 3, 4, 5, 6. So I've made 6 little bags, right? Oops. And 1, 2, 3, 4, 5, 7 little repackaged bags. But what happened, guys? Look at that. I still have peanuts left over, don't I? Oh my goodness, Chad. Chad, you're driving me crazy. Okay, I'm going to have to draw another 2-pound bag down here. We can make it work though. Chop. Okay, and then I'm separating this into 6 equal parts and 6 equal parts. Okay, I'm running out of different colors here, for goodness sakes. All right, I'm going to have to reuse. I'm going to reuse red again. Okay, so we're going to count 5 6 for yet another repackaged bag. So I'm going to start here. 1, and I'm going to go over to this one. 2, 3, 4, 5. That's another bag of these little ones. All right, here we go. I'm going to keep making bags. 1, 2, 3, 4, 5. 5, 6 again. 1, 2. Oh, I got to buy another bag of nuts, don't I? Because that's only 3 right there. All right, here we go. Chop it in half for the 2 pounds. 1, 2, 3, 4, 6 equal parts. 6 equal parts. All right, and I'm going to continue here. So I started a new bag right there. 1, 2, 3, 4, 5. So that is another repackaged bag of peanuts. I still have some to go here. Let's count again. And remember, I'm counting 5 out of the 6 equal parts because that's what's in each bag. 1, 2, 3, 4, 5. That's another one. And new color for a new bag. 1, 2, 3, 4, 5. We did it. We have 5, 6 right there. Chad used the exact amount in that bag, so he has no peanuts left over, right? So he stopped counting right there. let me see, he made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. He made 12 of these repackaged bags, but that's not what they're asking us, is it? Let's go back up into the problem. How many 2-pound bags of peanuts should Chad buy so that he can fill without having any peanuts left over? Okay, how many 2-pound bags, boys and girls? Remember, that's a 2-pound bag. So that's 1, 2, 3, 4, 5. Chad had to buy 5 bags. Okay? I hope he has like a peanut business or something. That's a lot of peanuts. All right, guys, so that was a beautiful example of how drawing a diagram helped. We just cut these pounds into the 1/6 pieces and counted out 5, 6, 5, 6, 5, 6, 5, 6, and kept going. We didn't give up. We persevered. Awesome work, guys. All right, now we're jumping down to number 4. A carpenter has several boards of equal length. He cuts 3/5 of each board. After cutting the boards, the carpenter notices that he has enough pieces left over to make up the same length as 4 of the original boards. How many boards did the carpenter start with? Wow. Was that like Information City or what? Oh my gosh, I have to go reread this one. A carpenter has several boards of equal length. So he has several boards. It doesn't say, but they are all equal length. So he cuts 3/5 of each board. So let's just do a board up here. Okay. How many parts should we separate this board into? 5. We're dealing with fifths. Okay, 1, 2, 3, 4, 5. So that's the carpenter's board, and he cuts 3/5, right, of each board. Okay, so I am chunking this, so I am really getting a visual. Now I'm right here. After cutting the boards, the carpenter notices that he has enough pieces left over to make up the same length as 4 of the original boards. How many boards did the carpenter start with? So we're not really even talking about the 3/5. In this problem, they're focusing on what is left over. So how much is left over after the carpenter cuts 3/5 off? There are 2/5 left over. So he keeps cutting boards and cutting boards and cutting boards, and then he notices that these pieces make up, here's what I'm reading, make up the same length as 4 of the original boards. So how many boards did the carpenter start with? All right. Wow, this problem's a whopper, isn't it? Okay, let's draw some boards. I'm trying to find a good color. I'm going to do black. It's easy to see. Okay, so we're going to just use the information that we have here. So he's got these 2/5 pieces of board laying around, and he found out that when he put them together, he can make 4 of the original size boards, same length. Okay, so I'm going to draw a board, and we know that all the boards are cut into fifths. Okay, so here he is putting together the 2/5 pieces. So That's 2/5, right, boys and girls? So those 2/5 came off of one of these boards that he cut. So there's the first piece he put down. Here's another 2/5. That came off the second board that he cut. So that's the first board he cut. That's the second board he cut. And again, that's the leftover from the boards he's cutting. And he's just stacking them all next to each other. All right, so that's just 1/5 there. So what we're going to have to do is draw another board. Okay, separate it into 5 equal parts. And 2/5, remember? That's what was left over from when he cut a board. So that's the third board he cut. That's left over 2/5, right? 1/5 plus 1/5. That's left over from the fourth board he cut. Guess what that's left over from? That's 2/5 left over from the fifth board he cut. All right, let's keep drawing. I'm going to make these touch. 1, 2, 3, 4. Okay, he had another pit. Now remember, let's go back to the problem for a second. He saw that 4 boards of the original size were made, okay? So there's the 6th board he cut, right? Right up here. He cut, right? He cut right up here. He has 2/5 left over. So he cut 6 boards. So every time that we have a set of 2/5, it's from another board that he cut. First board, second board, third board, the fourth board, the fifth board that he cut. So the 6th board that he cut left 2/5 right there. Okay, so then he cut another board, a 7th board, 2/5 left over. Got to keep drawing because he said 4. So that's 1, 2, 3. Here's the 4th board. Okay, so this board, remember, is made of those leftover pieces. So he put the leftover pieces from the 8th board he cut. So that's the 2/5 left over from the 8th board he cut. Another 2/5 left over from the 9th board, and another 2/5 left over from the 10th board. So for the carpenter to be able to make, there's the 4th one, 4 of the original boards, he had to cut 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boards. Okay, every one of these 2/5 pieces is the leftover from one of the boards. Leftover, leftover. Okay, if I hadn't drawn this original picture, because that really gave me an idea of what was happening. He had a board, and every time he cut 3/5 of it off, that was the leftover. So he pieced together the leftovers to make 4 of the boards that he started with, which we knew were 6/6. So we know he cut 10 boards. Now, guys, if I hadn't drawn a diagram for that, that would have been rough. Don't hesitate to draw diagrams, guys. Okay? Man, that was a whopper. Okay, here we are on the back. Lesson check. Karen cuts a length of ribbon into 4 equal pieces, each 1 1/4 feet long. How long was the ribbon? Oh, so we're in this one just starting with one long piece of ribbon. And Karen cuts it into 4 equal pieces. Okay? And each was 1 1/4 feet long. How long was the ribbon? So 1 1/4, 1 1/4, 1 1/4, 1 1/4. So how long is this ribbon, boys and girls? This kind of reminds me of what we did before with the commutative property and stuff. Look at these fractions, guys. 1/4 plus 1/4 plus 1/4 plus 1/4. You got it. 4/4. And then 1, 2, 3, 4. What's 4 4/4 equivalent to? Look at these choices. Right? Well, we know it's more than 4 feet. Okay? So it's 4 and 1 more. 1 whole more. So I'm going to write 4 4/4 as 5. Her ribbon was 5 feet long. Awesome. All right, down here at the lesson check. Not the lesson check, the, what is this called? Spiral review. We're down here at the spiral review. Okay, a frog made 3 jumps. The first was 12 5/6 inches. The second jump was 8 3/6 inches. The third jump was 15 1/6 inches. What was the total distance the frog jumped? So the frog jumped 3 times, 3 different distances. What's the total? So we're going to combine them or add them together. 12 5/6, 8 3/6. Let me circle these for you. And then the third, 15 1/6. Okay, remember, if you have 3 numbers with fractions, use your properties. Let's look at these fractions. Is there anything very pleasant that we want to add first? 5/6, 3/6, 1/6. Do I want to do what they tell me to do here in 5 plus 3? That's 8/6. Not a fan of 8/6. How about, do you see it, boys and girls? Do you see it? 5/6 and 1/6. So I'm going to use the commutative property, and I'm going to rewrite this. 12 5/6, C, C, commutative, commutative, C, C. Turn your head sideways to see it. Plus, I'm putting U next. 15 1/6 plus 8 3/6. Okay? Let's add 5/6 plus 1/6, 6/6. And then 12 plus 15. Well, you can do that over on the side if you want to. Right? 7, 2. Okay? 27 6/6. And then, of course, don't forget 8 3/6. 27 6/6. Well, 27 and 1 more, because that's equivalent to 1 whole. I'm not going to keep that 27. I am renaming you as 28. Okay, 28 plus 8 3/6. Well, we know that 3/6 is going to be our fraction. So look, I'm going to look at these choices right now. It's either going to be 35 3/6 or 36 3/6. So we have to add our whole numbers. 28 plus 8. Now look, if you're a sly mathematician, I know when I add my ones, 8 plus 8 is 16. I'm going to end up with a 6 in the ones place. So I already know which one is the answer, right? Let's do it up here, though, just to double check. 8 plus 8 is 16. 2 plus 1 is 3. 28 plus 8 is 36. Yeah, you guys figured that out, I bet, didn't you? You guys, this was a whopper of a lesson, but how awesome that you used everything you know about fractions. You killed it. Great work.